In this demonstration, I'm going to show you the difference between a series circuit and a parallel circuit, and look at the significant physics of both. What I have in front of me is a driving lawnmower battery that's rated at 12 volts. And I've labeled the front positive terminal here and negative terminal here, and below those show numbers that represent what's called the electric potential. I've assigned this side 12 volts and this side 0 volts, so that the difference between the two is the rating of this battery being 12 volts. That difference represents the voltage, which can be a little confusing sometimes. This battery, because it's negative on this side, what that means is there are an excess number of electrons on this side, especially compared to this side. That means there are more electrons here than protons, and on this side there are an absence of electrons, making it more positive. So we have a positively charged side and a negatively charged side. When I connect these two wires together, the electrons here sense that their positive counterpart is over here, and they want to get over there as fast as they could. So they feel pressure or a force on them that drives them over there. And that's how we create current, which is the flow of electrons in a circuit. What I'm going to do is I have 3 light bulbs. We're going to create a series circuit first. And I'm going to place this one on the 12 volt side and then the other end on the 0 volt. Now, I could have said this is positive 6 volts and this is negative 6 volts, and that still would have given us the same difference, which is 12 volts. And that's what we're looking for, but I made it easy and assigned that 12 and this side 0. When I do that, that difference in voltage puts pressure on the electrons to drive them through this light, giving their energy away to the light, and by the time they get to the other side, they have no more energy. Now, electrons actually flow from the negative side to the positive side, but Benjamin Franklin considered and envisioned positive charges as the thing moving, and so we actually have a convention that has stayed, and we have taken on that convention to be that current, or the flow of electrons, would go from positive to negative, even though we actually know that they go from negative to positive. So I'm going to say that current always goes from positive to negative, adopting that same convention that Benjamin Franklin had used. And that means the flow of charges goes from the high electric potential, 12 volts, to the low electric potential, 0 volts. Okay. What would happen if I connected another light bulb in series? So if I take another light bulb and connect it directly with this one, make a prediction on what would happen. Would it stay the same brightness? Would it get brighter? Or would it be dimmer? So let's go ahead and try. These 2 light bulbs just got dimmer. So you can see that we have the same electric potential difference across both of them. It goes from 12 to 0, and now the light bulbs are dimmer, and we'll talk about why that is. And if I put a third one on there, what do you think would happen? Brighter, dimmer, or the same? You might have guessed it. It's going to be dimmer. So when I put the third one on there, it's much, much dimmer. Okay, so now you can barely see them. So that is a series circuit. Now let's take a look at something called a parallel circuit. This time, I'm going to connect the top one up here. And a parallel circuit is like rungs of a ladder. So I'm going to connect these ones next. And you may make a prediction of what you think the brightness of this bulb will look like when I connect it to this side. Brighter, dimmer, or the same. It's the same brightness. What you'll notice is the potential difference, the difference between these 2 numbers, 12 and 0, is the same from this point to this point, because it's 12 volts here on this rod, it's 12 volts here on this rod, it's 12 volts here, it's 12 volts here, it's 12 volts here. On this rod, it's always 0, 0, 0, 0, 0, 0 along any point on that rod. And the difference is what's driving the current through these light bulbs. And it's that voltage is actually the pressure on those electrons. If I put another one here, let's see what happens. Same brightness. But of course now we're draining the battery faster. We're spending more energy to light these up equally. So now this battery will drain much faster. That's a parallel circuit. Let's take a look at the physics behind the series circuit and the parallel circuit. Let me start by introducing the concept of voltage. Our battery was rated at 12 volts. That is the rating of the voltage. That means that on the left, we have a positive terminal at plus 12 volts. Volts is the unit of something called potential. And on the right, we have it at 0 volts. Now, it's the difference of these two numbers, 12 minus 0, that gives us the 12 volt rating, which is significant. Let me start with an analogy using gravity. Gravity has something called gravitational potential. Gravity potential is related to the height. If I have a platform with a ball on top of the platform or on the ground, and on the left it has a height of 0 meters, and on the right there's a height of 0 meters, the ball will stay at rest. Nothing's going to make this ball want to roll. However, if I then have a platform or surface that is 12 meters on the left side, 0 meters on the right, then there's a slope, and if there's a ball on top, this ball will want to roll and move. It is this difference in height, and here we would say a difference in gravity potential, that makes the ball want to roll. The same thing goes for something called electric potential. Electric potential is based on how charges move. If we have not a ball this time, but an electron, and we place it where the potential is 0 volts, and over here it's 0 volts, this electron or charged particle will not want to move. However, when we put the electron where there is a difference in potential, say 12 volts on the left, 0 volts here, this puts some pressure on the electron, making the electron want to move. It's these electrons moving, which we call current, that allows us to put something between these and give us light or do work, giving us power to objects. So if I have a light bulb and I put it between the two, electrons begin going from high potential to low potential, or at least we say by convention that's the direction of current, and we get light. Here's how to understand why the brightness of the light bulbs in the series circuit is dimmer than the brightness of the light bulbs in the parallel circuit. There is a physics law known as Ohm's law that talks about something known as resistance. Each light bulb has a resistance, which I'm going to call R. And because of this resistance, the electrons that are trying to go from the 12 volt side of our 12 volt battery to the 0 volt potential side are actually being resisted by each of the light bulbs. When all three of those light bulbs are in series, their resistance adds, and therefore we get a dimmer set of light bulbs. On the right side, we have three positions along the left pole that are each 12 volts for our 12 volt battery. So these are all 12 volts. And on the right hand side, each of these points are 0 volts. The resistance between each of those potential differences is just 1 R for each of them. It is the resistance between the potential difference that causes our light bulbs to either be brighter or dimmer. And in the case of the parallel circuit, they're much brighter because we're not resisting as many electrons flowing through the circuit. This is known as Ohm's law.